So the medium-sized triangle, again, it should look the same. You're making it so that they're in the same orientation. The medium triangle has the 90-degree angle as vertex A. Up top here is E. And then this is N, correct? Are we all in agreement for the medium-sized triangle? And the small little guy is going to be N, M, and A. Is this correct? What's up?
Wouldn't the right angle be on the end?
Okay, can you sit loud? So I was asking in earnest, is this correct? We all agree with this? Alright. It's okay to question. It's okay to question your teachers. Don't be disrespectful about it. But it's okay to question. What's up?
Is it okay if like we do triangles different?
I asked for that all the right angles were in the left-hand corner. So follow my directions. This is the way that I wanted them to be. But when you're drawing them on your own homework and your quiz and your test, however you want to draw them is the way you want to draw them. The reason we're doing this is so that these triangles are now in the exact same orientation. So it's extremely easy to identify what are the corresponding angles and parts and so on and so forth. So when you were trying to find item 2, why are these triangles similar? Louder. Angle, okay, good. So we know that these triangles are similar angle, but in order to use angle similarity to prove triangles are similar, you need to tell me what angles, what are congruent. Which 2 triangles are these? This is the small, medium, or large? Which 2? Small and medium. So right now, what we're showing, what we're justifying is that when this situation arises, that you have a right triangle with the altitude to the hypotenuse, these 2 smaller triangles are formed, and they are similar. They're similar because of angle similarity. In this diagram, you have that angle NMA is congruent to NAE, and angle ANM is congruent to angle ENA. It's extremely more easy to look at this diagram that we've drawn on our own and identify the corresponding angles rather than trying to figure this out. We agree? So this is, you don't have to do this, but this is the way that my mind works. I mean, I can figure out the corresponding angles, but it's much easier just to look at this. So whatever 2 angles you wanted to write here, just make sure that they truly are congruent corresponding. But you need to have the 2 angles that you are using to prove that these triangles are similar by using angle. What I have currently written on the board, this would maybe be 50% credit if it's a good day when I'm grading. You need to tell me how are you using this theorem. Where are the 2 congruent angles? And like I said, the 2 that I used was NAE is congruent to angle NMA, and then I used the 2 right angles. Those are the 2 angles I used, but you could have used the other ones as well. Please use the 3-letter process when naming each one of them. Item 3. So we just showed that the 2 smaller triangles are congruent. Item 3 says the large triangle is also similar to the 2 smaller triangles. Complete the similarity statement, naming the large triangle appropriately. Emphasis on appropriately. What do they mean by appropriately? What does that imply? Using the 3-letter process, that's the only way to name triangles. What else do they mean? Can I just put the letters in any order? Matching corresponding parts, matching corresponding vertices. So the only correct answer here, triangle MAN is similar to triangle. What's the only correct answer? Should be MAE. No. Sorry. MEA, right? Sweet. Now, on a quiz or test, this is what you're going to have to do. I'm going to give you a diagram that's extremely similar to this. It may be rotated or reflected or whatever, but you're going to have a right triangle with this altitude drawn in from the 90-degree angle to the hypotenuse. And you're going to have to write a similarity statement that relates all three of these triangles. A similarity statement is just a statement stating that things are similar. Two or more things are similar. So if I'm asking you to write a similarity statement for the three triangles in this diagram, what I'm looking for is this similarity statement. That triangle EAM is similar to triangle ENA is similar to triangle ANM. That is a similarity statement that is relating all three of those triangles in there. And I have named them appropriately. All the corresponding vertices are matching up. All the corresponding angles are matching up. All the corresponding sides are matching up. So this is the similarity statement relating these three triangles. This is a quiz question. This will be a test question. This is a homework question. So this is what they're talking about when they want a similarity statement relating all three triangles. Item 4, the last one of this chunk, if you will. It says, name the type of special segment, segment AN, in the relationship to triangle MAE. What is it? Altitude. Not a trick question. We're learning the right triangle altitude theorem, so yes, that is an altitude. Before we move on, it is a correct statement, and it is correct that you answered. This segment here, segment AN, is one of the altitudes of that large right triangle. Can anyone name me another altitude that's drawn? What is another altitude of the large right triangle? Say it louder. Segment AE, I agree with that. So one of them is segment AN, another one's segment EA, or AE. What's the third one? Altitude of the large right triangle. MA. Whenever you have a right triangle, the two legs are two of the altitudes because they're perpendicular to one another. So in this large right triangle, this is one of the altitudes, this is another altitude, and then this one that you have to draw in, that is the third altitude. We are concerned only about this altitude. The right triangle altitude theorem is only dealing with this one. Because when you draw on this one, that's when your other two right triangles are formed. Let's focus more on that segment AN. Segment AM is unique to every single one of these triangles. When you drew the three triangles off to the right here, do you notice that every single one of them has a hypotenuse, and every single one of them has a short leg, and every single one of them has a long leg? We all see that? Okay, so segment AN. With respect to the large right triangle, it is one of the altitudes. However, Chris, what is segment AN with respect to the smallest right triangle in that diagram? It is one of the altitudes. What else is it?
One of the legs.
Short leg or long leg?
Long leg.
It's a long leg of the small triangle. That same segment AN is what part or what side of the medium right triangle, Kyle?
Line segment AN.
Huh?
It is an altitude.
It is? What about the side lengths though? Is it
Short
type?
leg.
It is the short leg. So we need to be able to do that because we're going to start relating the short legs and the long legs and the hypotenuses. So you need to understand that, for instance, like segment MA, that's a hypotenuse. It's also a short leg. Segment AE, that's a hypotenuse. It's also a long leg. We need to be able to recognize the uniqueness of each segment with respect to the three triangles. They act as different segments, and we're going to be looking at those values. And that's where these corollaries are coming from. So using that knowledge, what we just talked about, these triangles are similar. I want you to answer item 5. Tell me the length of segment AE, tell me the length of segments MA, and tell me the length of segments MN. I need all three of those lengths. Okay, so for these three lengths, what is the length of segment AE and how did you solve for it? Someone raise your hand. Jensen.
I got 15
15 what?
inches.
15 inches, and how did you solve for that?
11 over 9 squared plus 12 squared is 6 squared, and then I added these up.
Perfect. So we used Pythagorean theorem when we got 15 inches. The length of segment MA, what did we get? How did we get? What's the value talking?
I just got 11.25 inches,
Okay, good.
and I
That's
did 15 over AM equals 9 over 6.75.
How did you get 6.75 for that one?
Because I did MN first. I found one for MN first.
Okay, cool. Very cool. So you used a proportion. The fact that those triangles are similar. You got 11.25. If you left it as an improper fraction, that should be 45 over 4. And then segment MN. What is the length of segment MN? How did you get it? What did you do? Or what is it? And what did you do? It's okay, you talk to me.
6.75 inches, and I put the proportion 9 over 12 equals NN over 9.
Beautiful. Awesome. So in the directions it said for us to use Pythagorean's theorem and the fact that, well, we just proved these triangles are similar. And if the triangles are similar, then we know that the corresponding sides are proportional, therefore set up a proportion. So, awesome. That's pretty much 90% of your homework. Is identifying those three triangles, knowing that they're similar, and then setting up a proportion. If we move on to the next page, 276, that is where we have this theorem and where we have to prove it. Now, if you look over to the left, it gives us the theorem in full. And this theorem is in the if-then form. Well, over here, item 6 asks us to complete a proof of this theorem. It's extremely important that you know this, that whenever you are asked to prove a theorem, you have to come up with the given statement, and you have to come up with the proof statement. But it's not that difficult. Whenever you are proving a theorem, it's in the if-then form, it's a conditional statement. Your hypothesis is what you're given. That is what you're given. They're saying, hey, if this is the case, or if this is the given situation, that an altitude is drawn to the hypotenuse of a right triangle, then prove, then conclude your conclusion that the two triangles formed are similar to the original right triangle and to each other. Easy way to say all that is the three right triangles are similar. But that's how you prove a theorem. Your given statement is the hypothesis, and your proof statement, what you're trying to prove, is your conclusion of that theorem. So that's exactly what we're doing over here. We are given the hypothesis that we have this triangle with a right angle, so it's a right triangle, and we have the altitude that's drawn to the hypotenuse. Then we have to prove that all these triangles, the triangles that are formed, are similar to one another. This is how you prove a theorem. So let's go ahead and complete this. Hopefully you know what item 1 is, so go ahead and fill out statement number 1.